Hi, welcome back to CMG-MathSpace, your home of pure math and elective math. This is AKI-OLA core math series for SHS students or someone who would like to learn math. Now, we have been away for some time now, but in fact, without further ado, let's continue with our series on real number system. At the moment, we are on standard form. We may take about 3 episodes of this particular subtopic. I'm going to read, explain, so stay tuned. Now, standard forms, right? Sometimes we come across very large numbers or very small numbers in our daily lives. It becomes very cumbersome to express such numbers in their full form. Calculations with such numbers would also be very difficult. Therefore, when numbers become very small or large, standard form or standard index form is used to make them convenient or more manageable. Right. So what it means is that we are dealing with real number system where we talk about fractions and all sort of numbers. So when numbers are too small or too big, there's a way to make them convenient or easy or manageable to do or deal with. So that is why we have the standard form. We have the decimal places and all that. We have dealt with them, right? So now let's look at standard form very closely. When I was a student, SHS for that matter, I really had it very difficult understanding the whole of the real number system, right? When it comes to the explanation or the definition of what is a real number, they were easy. But when it comes to practicality of the practical form, it was very difficult for me. Upon that note, this is why we are doing this, right? So now, therefore, in the standard form, right, numbers are written in such form. We have a times 10 raised to the power n, and this is the standard form, right? Now, if that's the condition, if 1 less than or equal to a less than 10, and n is integer, so n should be integer. Integer can be a positive or a negative whole number. That is the note. That is what the n. Now, when you look at a, we are saying that a should be a number between this the range of 1 and then 10. So it means that it can be equal to 1 but not more than 10. So the maximum could be at least 9.9. So that is it, right? Then not less than, right? So equal or less. In fact, this is the condition, right? So less than or equal to 1, right? What am I saying? It should not be less than 1, right? So that is the point to note. Yes, so let me take that condition again. So a should be less than, it could be equal to 1 or greater than 1. So that is it. Let's take that condition again. We treated the conditions when it comes to the inequality sign, right? So a can be equal to 1 or more than 1, but not greater than what? 10, right? Not greater than 10. So if you want to understand it better, you can take only this aspect of the condition, one condition, and then come and take it again, this. So we can divide it this way. So that is it. So that is the point to note. If you are getting confused, let me know. I will address it in the comment section. Now, so let's continue. Now, example, we have 8.72 times 10 raised to the power 6. And then we have 2.5 times 10 raised to the power negative 4. So these are all standard form. So by the moment we come to meet 87.2 times 10 raised to the power 10, it makes it wrong because this is far greater than what? 10. It's far greater than 10. So that's the problem. Now, and then we have here this 0.5. Now, this is less than 1. This 0.25 is way less than 1. But we said it should be equal to 1 or greater than 1. So that is the condition, right? Now, and are not in the standard form. These are not in the standard form because it is okay, we have the explanation here. 87.2 and 0.25 are not written from 1, right? But less than 10. Now, the value of n, that is the index of 10, right? And the power, when you say the index, is the power ratio that we are talking about, of 10 in standard form shows whether the number is greater than 1 or a fraction, right? So it only tells us is it greater than 1 or only a fraction. So that's the point. Now let's look at some conditions, right? You don't really have to memorize them, but they will come up naturally if you understand the concept or you do the calculation correctly, right? So now we are saying that if n, right, that's the ratio, what? The ratio, the power ratio or index, that's the n. If it is positive, the number is 10 or more. So for example, we have 1 times 10 raised to the power 1 is the same 10. That's what they are saying. Example, 4.6 times 10 raised to the power 6. This is the calculation that we have. So what does it mean? Any number raised to the power n or ratio, it means that we are multiplying that number how many times? 6 times. For instance, we have 10 raised to the power 6. So it means that we are multiplying 10 by 10 by 10 by 10 6 times before you come and multiply this. That's the calculation. But because this could be cumbersome when we are supposed to do it naturally or per even calculator, that will be a cumbersome calculation, right? So the standard form tries to shrink or make things manageable, right? So we told you that for our purpose or the objective of this particular series is for us not only to know how to do the calculations and then leave or get the correct marks or pass the exam, but to understand and then for it to become part of our life, right? So if you understand this, no matter how advanced you become in education, these fundamentals will never leave you, right? So that is it. So we need to understand the concept, why this is so, or why do we even need, or in the first place, transfer or do calculation in standard form. So that is an important thing to me, right? Besides that, I want you to understand or do this or pass your exam. I want you to understand. Many a time, we say this, like the blacks or the Africans says that, why would you do certain things when there's no need or importance to that? But sometimes these calculations that we do really matter, right? So but we see them in advanced levels when we are doing maybe mechanical engineering or civil engineering or being a mathematician. That's where people get to realize, okay, this is it. But at the average or elementary level, we think these are not important, but they are very important the moment we advance in math. So that is the idea. So now, if n is 0, the number is between 1 and 10. So for instance, 1 times 10 raised to the power 0. Any number raised to the power 0 is 1. So 1 by 1 is 1. So 4.6 times 10 raised to the power 0 is 1. So we are getting the same value, which is 4.6. You understand? Now, there's one note that I need to let you know. Right, we said if n is 0, the number, you may be asking, I don't know if you are very sharp student or someone who is very observant, you may be asking, what number are we talking about? The number, meaning at the end of the resultant calculation or the resultant number, that's what we are talking about. So after doing the calculation, the number or the answer, right? So that's what we mean by saying the number. So that is it. Now, if n is negative, the number is less than 1. So let's see. For instance, 3 times 10 raised to the power negative 1. See, the solution is 0.3. And this, we are saying that this is less than what? 1. So that's what it means. 0.3 is less than 1. And they are saying that the number is less than 1. So this is the number, and this number is less than 1. So to understand and use standard form, you must be able to multiply and divide by indices of what? 10. Right? So that's just by the way. Now, let's go to some multiplications. You are multiplying by positive index of 10. So it makes the number integer larger. So we have this one, 4.6 times 10 raised to the power 6. So we see the same thing here. Multiply by a negative index of 10. Right? 4.6 by 10 negative 3 by raised to the power negative 3. This is what you have. Right? So we are multiplying. When you are multiplying, the zeros multiplied by negative index, the zeros comes to what? Trend or thread in front. So that is it. So how many zeros here? I don't want to explain this. I better understand you understand why this is so. So we see in the next one. Bye for now.